All right, this is pre-algebra lesson 10.7. Volume of prisms and cylinders. I gotta clean this screen. Okay, here's the deal. I'm gonna, you've seen objects like this. Let me draw it for you. Three-dimensional, right? You can see it. You can see that that's three-dimensional. You all can wrap your brain around that. Okay. Okay, you can see that, right? That looks like a bunch of blocks, that are put together. Okay, so let's talk about lengths here. Let's talk about the lengths. This distance here is how many? This is 5, right? There's 5 blocks across that. Agreed? You see them? Okay. And then what's the length here? 3. And then the height? 4. Right? Does that make sense? Okay. Here's the deal. I'll explain to you how you do it. You could probably, that you multiply base times height, base times width times height to do a rectangular prism like this. But I need you to understand, this is what happens. This is what's cool, is any prism, I don't care if it's an octagonal prism, I don't care if it's a hexagonal prism, I don't care if it's a decagonal prism, I don't care what the prism is, triangular prism. The rule is this, it's volume, and you're going to want to write this down, right, so that you have it. Volume is, notice this, what did I put here? What is that thing? Base. It's a big B. Oh, it's a big B. There's a difference, right? Before, if I wanted to give you the area of something, I would go B base times height, right? Small b times height. Agreed? Ooh, this is the volume is big B times H. Big B. You know what big B stands for? The area of the base, right? The base's area. So then what is the base here? What is the dimensions, not the base, what is the dimensions of the base of this thing? 5 by 3, right? It's 5 by 3. That's the dimension. So then the base would be 15. Do you agree? The base is 15. So here in this situation, what we're going to do is this. Since it's V equals BH, we go volume equals. What is the base? That would be 15 whatever units squared, right? Because it's 5 times 3, 15 times the height, which is 4. 15 times 4 is, the volume is 60. And you can look at that. I mean, can't you look at this and kind of visualize it? Take the whole top row here. Let's take this top. Let's take these top blocks and lift. How many are there in that top layer? There's 15 in that top layer, right? And then you go, well, how many layers are there? There's 4. It's 15 times 4. You should be able to visualize this and understand where we come up with 60. This is not just some, oh man, crazy. I just know I need to multiply base times height times, no. You should be able to see this and figure out, oh, there are 60 of these little 1 by 1 blocks. Make sense? But the formula doesn't change. Let me give you another one here. What about this? What if I have a triangle? I need to draw that a little bit of an angle. Okay, do you see it? You visualize the triangle, the triangular prism, right? Okay, so then let me do this in purple so you can see it. Here is the height of this thing. How do you know it's the height? I put that little 90-degree angle, right? I mean, I'm letting you know that's the height. That is 90 degrees. So that is, okay, that's the height. We'll say that is, we'll say 6 centimeters. Okay. And I'll tell you that this right here, well, I'll go over here. This is 5 centimeters. And this here is 12 centimeters. So, here's the deal. What do you need to know? This is actually a good one. I like this. Ooh. What do you need to know in order to do this? So I need, first of all, what's the formula for finding the volume here? V equals big BH. Okay. What is the base? It is not 5 times 12.
6 times half times 5 times 12.
No. You need to listen. You need to visualize this, okay? It's talking about the base of the it's talking about the area of the base of the prism. What is the base of this prism?
Triangle.
The triangle is the base of this prism, right? That's not the base. That's one of the lateral faces, right? The base is if there's a prism, it's the two congruent sides, right? That are parallel with each other. That's the base. So you have to find the base of so what's the base of this thing then? What is the dimensions? It's 5 is the base times 6, but what's the rule?
1/2.
Half, right? So to find the area of the base, to find big B, to find the area of the base, here's my triangle, people. Right? This is 6, and this is 5. What do I do?
What would be easier is you multiply base times height times 1/2.
Right, it's 1/2 of the base times the height, right? So then 5 times 6 is 30. Half of that is 15. So the big B is 15. So we go volume equals 15 cubic centimeters, not cubic. Yeah, well, we'll get to that. It is cubic here, but actually it's cubic. It's squared centimeters right now. What is the height then?
12.
It's not 6. That was the base. Remember, we've turned it up on its bottom, and so there's the base down here.
12.
What's the height, Gigi? Do you see it though? Don't just say it because Jack says it. I mean, do you see that it's 12? Listen, just because I laid it on its side does not mean the base is still, right? I mean, it happens to be on the side right here, but when you lay it up here, what's the height? 12. Does that make sense? You have to be able to throw this thing up in your head. It's on its side on the board, but you have to be able to throw it up in your head. It's 12 times 12. What's 15 times 12? 180. Now, here's the deal. It's not squared inches. Squared inches is how much carpet. Cubic is talking about how many, boom, 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 how many cubes there are, right? How much space is there inside of this baby? So that would be cubic centimeters.
Oh, so just you write a 3 instead of 2.
That tells you that it's cubic. 3-dimensional figure, right? We're talking about a cube. Okay.
So for even for the triangular prism, you write that?
What?
Even for a triangular prism, you write that?
Yeah. Okay. What about this? They give this example here. Now, I am not going to make you do this one, but I do want you to explain to me how would I find, that is ugly right there. How would I find the area? No. How would I find the volume of this object? I want Gigi to explain. Just tell me. How do you find the volume of this object? Awesome. So what do I need to do? You tell me. Yes, you're right. V equals capital BH. What does that mean? What is the base? Explain that to me. Yes, you got it. But what is the base? What does that mean? What is? Right, so you find the area of that base, whatever that is. Now, I'm not even showing you how to do that here. Doesn't matter. But you find the area of the pentagon, right? And then what do? By the height, and you're done. Find the area of the pentagon, multiply it by the height. That's the cubic dimensions of this thing. Make sense? Okay. What about this? Nothing changes here. Explain to me how to find the volume of this, Sheena. Find the area of the base, which happens to be a circle. Then multiply by the height. Find the area of the circle, multiply by the height. So if I gave you this and said, okay, the radius here, this is 4 centimeters, and the height here is 6 centimeters, what would you do? What would you do, Jade? Multiply them? We're finding the volume here, Jade. No. Yes, but how do you find the base? What is the base? Is 4 the base?
Oh, no.
Is 4 the base at all?
8?
Is 8 the base? What are you talking about? How do you find we have to find the area of the base. It's big B. Volume equals big B times height. That big B means the area of the base. How many square centimeters are there in this circle? How do you find the area of a circle? Everybody, how do you find the area of a circle?
Radius.
Pi r squared. Right? You have to find the area of the base. You have to find out how many 1 by 1 inch squares or centimeters there are in, right? So you're finding the area of the base, whatever that is. Dude, how do I find the area of this base? Tell me exactly what to do.
Pi r squared.
How do I do it? Tell me. Don't just say it. Tell me.
1/4 times 4, second hour. So, 3.14 times 16.
What is 3.14 times 16? Notice I'm just bringing the V down. I'm bringing the B down instead of a B. It's 50.24. What's the height?
6.
What's 50.24 times 6?
301.44.
301.44 centimeters cubed. Right? You have to find the area of the base. Find the area of the base. That's what big B means. And then you multiply it by the height. Is that difficult? No. Just like this. It's no different. All these cylinders and prisms, we'll do another one just so we can be absolutely sure that you get it. This is 5 inches. This will be 7 inches. This will be 3 inches. What's the rule defining the volume? If I want the volume here, volume equals, what's the rule, Jade? V equals big B times H. So what does V stand for? Volume. So the volume equals, what's big B stand for again, Jade? Base. What do you mean base? Don't just say base. It's the area of the base. Okay, what's the area of the base?
35.
Right, because these are the dimensions, 5 by 7. It's 35, right? Times, what's the height? 3. 35 times 3 is 105. Volume equals 105 cubic inches. And we're done. Find the area of the base, whatever it is, and multiply it by the height. If I told you that this object right here I told you that object, that the base down here, that the base was 47.2 squared inches, and I also told you that the height of this object was 5 inches. What would you do, Jack?
You multiply 5 times 47.
Oh. You have to find the area of the base, multiply it by the height, you have your volume. Difficult? Your homework. Yep.
So we put the cube.
Got to have cube, because listen, this is so important. What does something squared, show me with your hands, what does something squared mean? No, squared does not mean this. That's a distance. That would be nothing. Squared would be like this, if I was to, you know what I mean? Like there, it's a piece of cloth. A piece of toilet paper is something that is squared. It's this, right? I mean, it's two-dimensional. right? Show me something that's three-dimensional. How would you explain that? Right, or you would go like this, right? Three dimension has depth, right? So if you don't put cubed, we're talking about, if I was talking about we'll do this room really quick before I give you your homework. Here's this room, right? Here we go. And here will be the stage is right up here, right? Here I am standing here at the stage. Does that make sense? Can you all see the room? Right? Here you are sitting in here at your tables. Can you all see the room? Okay. We'll say that this is 40 feet. And we'll say that the length, that would be this, 40 feet. We'll say that length over there is 30 feet. And we'll say the roof is 10 feet is the height of the room. What would I be asking? If I'm asking for the volume, what am I asking about? What would I be asking about? What might I ask? Why might I ask about the volume here?
How many, like, 1-foot boxes are in the room?
How much air is in the room? How many 1 by 1 foot cubes of air are in this room? Do you understand what I'm saying? I want to know how much air is in the room. And so you'd have to take a box, an invisible box, and set it in the corner. And then go put another one right next to it, another one right next to it, right? I mean, wouldn't it look like this? Wouldn't it just be this, right? And then there would be height, right? Does that make sense? I mean, like we're talking about, so how many boxes of air would there be in the room? What do I have to do? What do I have to do, Gigi? That's the area of the base, right? So volume equals the area of the base, big B times H. Volume equals, what is 30 times 40? 1,200. That means there would be, if I was to take these boxes, 1 by 1 foot boxes, and set them down here in the corner, and just start doing it, then it would cover the floor. It would take 1,200 of those boxes to cover the floor. Oh my, right? And then, am I done? Would that fill up the room? No. Show me what it would look like. What would it look like? It would just be like this tall, right? All the way across the room. Right? 1 by 1 foot box. So what do I have to do? Do another layer, right? I have to do another layer. How many layers is there? 10 layers. So then I would have to multiply that by 10, which is 12,000 cubic feet of air, right? There are 12,000 of these 1 by 1 foot boxes. If every time we took a breath, we used 1 cubic foot of air, how many breaths can we breathe in here before we run out of oxygen? 12,000 breaths. If we did that, it would take 12. We would have done 12,000 breaths. We'd be done. Make sense? So then, you want to know how much air we have in this room. If all of a sudden they shut down, they shut everything down, and we had to lock in, and we couldn't go outside. Well, us 6, we would have 2,000 breaths each. If we take, let's just say, 10 breaths a minute. How many minutes do we have? If we each have 2,000 breaths. If we have how much? Listen, if we have 2,000 breaths, and we each breathe 1 breath every 6 seconds, or 10 breaths a minute. How many minutes of air do we each have?
20. No.
2,000 and 10 per minute. 200 minutes. 200 minutes is 3 hours and 20 minutes. We would have 3 hours and 20 minutes of air in here if we... Now, we don't use a whole cubic foot of air when we breathe. You know what I'm saying? We don't. And we also breathe a lot less than 10 breaths per minute. So we would probably, in here, just in this room with us 6, we probably have, 12 hours of air. 10 hours of air. So it's a long time. We don't have to worry about running out of air if we ever have a lock-in. Does that make sense? Okay. Anyway, now I give you your homework. Today's Friday, it's page 559, 1 through 6, all, and 10 through 13, all. There you go. Yeah.